Hi everyone. So now let's do this question. Okay, here the question is, for the network shown, find I1 by V1, I2 by V1 and I2 by I1. Okay, so this is the circuit, and like I said, this is also a non-ladder circuit, which means this is like your ordinary circuit. So which means if you want to find the value of these network functions, you need to apply nothing but Kirchhoff's voltage law. That is your symbol. This is nothing but symbol mesh analysis. Okay, so these are all network functions, which means these are all in terms of Laplace transform already, this I1, I2, V1 and all. Okay, so here what you need to do is you need to find the Laplace transform of all of these elements. Okay, and since they haven't mentioned anything about initial conditions, you can assume that all the initial conditions are all equal to 0. Okay, so in that case, first you draw the Laplace transform of this circuit. Okay, here you see there's a capacitor 1 Faraday, another capacitor 1 Faraday, 1 ohm and another 1 ohm resistor. So let's draw the circuit. So hence the transform network is given below. Okay, so this is the circuit. So let me draw the circuit. So the circuit will be, you'll have a voltage, it is V1. Some of you will be having a confusion, like you see, if the Laplace in the previous videos, the Laplace transform of V1 is a voltage, the Laplace transform of V1 should be V1 by S. Okay, what you're saying is correct, but that is correct, but what you need to understand that this V1, I1 and I2, all those two-port parameters V1, V2, I1, I2 that you have learned in the previous videos, those are already in terms of the Laplace transform. Okay, so that's why you don't have to apply Laplace transform again to these values. All you need to do is apply Laplace transform only to these elements. Okay, that is why. So that's why I'm not converting this into Laplace transform. Nobody ever finds the Laplace transform of a Laplace transform. So this is already in the form of a Laplace transform. That's why we don't have to apply Laplace transform to this parameter. Okay, you see a capacitor here. So what is the value of this capacitor? It is 1F. It is the Laplace transform is 1 by Cs. So the value of C is equal to 1F, right? So value C, so you'll get 1 by S. So this is 1 by S. The impedance of this capacitor is 1 by S. The impedance of this resistor is 1. The impedance of this capacitor is again, it's 1 Faraday, so that is also 1 by S. And you have another resistor over here, 1, and this is another resistor. This is also 1. So this is the circuit. Okay, I1, here you have I2, and that's it. Okay, that's all. So now you are asking us to find I1 by V1, I2 by V1 and I2 by I1. So I1 and I2 is already marked over here. So if you're going to look at the direction of this current, okay, if you want to mark the direction of the current, you need to follow these direction itself. The direction of the mesh current should be in accordance to the direction of this currents. So if this is I1, then this is how you're going to mark I1. If this is I2, then this is how you're going to mark I2. And then only one more current is left, that you will mark it as normally as usual. And I1, I2 has already been booked, so I think we will use the word name I3. So this is how we mark the currents. So now let's apply Kirchhoff's voltage law. This is mesh 1, this is mesh 2, and this is mesh 3. So applying. So now from here onwards, this is nothing but your normal Kirchhoff's voltage law problem that you have did so many times. There's nothing new to do over here. Applying KVL to mesh 1, let's write the current. So here you have I1 into, I1 is touching these two parameters, right? It is 1 plus 1 by S. 1 plus 1 by S. And what about I2? If you look over here, I2 is touching only this resistor, and both I1 and I2 are flowing the same direction. So it will become plus I2. Plus I2 into 1. Okay. And what about I3? I3 is flowing in the opposite direction of I1, right? Because if you look over here, I3 is touching only this capacitor, and I1 is flowing from left to right, but I3 is flowing from right to left. So it's opposite direction. So it's minus I3 into 1 by S is equal to v1. Okay. Say anytime when you see these kind of equations, okay, and if you see a denominator like this, right, it's always better that you remove the denominator from there, so it will make the equation more easy. Okay, so I will remove the denominator and I will get how do I remove the denominator? Multiplying this entire equation with s. Before that, let me write like this: s plus 1 by s plus I2 minus I3 by 1 by s is equal to v1. So how to remove the denominators? Multiplying by a common factor. So here both the denominators have s over here, right? So which means I will multiply this entire equation with s. What will happen? S and s will cancel. This will be multiplied with s. Here also s and s will get cancelled, and here this will also be multiplied with s. So you will get I1 into s plus 1 plus I2 into s minus I3. S and s got cancelled, and here this will become v1 into s. This is the equation 1. Okay. Now I am going to apply KVL to mesh 2. So what is the equation? Here both I1 and I2 are in same direction, so it is plus I1. And I1 is touching only that this 1 ohm resistor. What about I2? I2 is touching these 3 elements, right? That is 1 plus 1 plus 1 by s. 1 plus 1 is 2, so 2 plus 1 by s. So this becomes plus I2 into 2 plus 1 by s. And what about I3? Yes, both I3 and I2 are also flowing the same direction, right? Because if I3 is touching only this capacitor, and both I3 and I2 are both flowing from right to left. So that is also plus I3 into, and here you have 1 by s is equal to, no voltage or anything like that, so it is equal to 0. This is it. Okay. Again, I need to remove this denominator s because I don't like it. I plus I1 plus I2 into, this will become 2s plus 1 by s plus I3 into 1 by s is equal to 0. Multiply the entire equation with s and you will get I1 plus I2 into 2s plus 1 plus I1 into s, sorry, just I1 into s, because you are multiplying the entire equation with s, right? So this will become I1 into s, I2 into 2s plus 1 plus I3 is equal to 0. Okay, this is how the equation will look like. So this is equation for mesh 2. Now next is applying KVL to mesh 3. Okay, so you will get here both I1 and I3 are flowing in the opposite direction, so it is minus I1. So it is minus I1 into 1 by s. And what about here? Here both I1, I3 and I2 are flowing in the same direction, so it is plus I2 into 1 by s plus I3 into, and what about I3 is touching these 3 elements, 1 by s plus 1 by s plus 1. 1 by s plus 1 by s is 2 by s, so 2 by s plus 1. So it is 2 by s plus 1 is equal to 0. Okay. Or another, this can also be written as minus I1 into 1 by s plus I2 into 1 by s plus I3 into this can be written as s plus 2 by s is equal to 0. Okay, and here multiplying the entire equation with s and you will get minus I1 plus I2 plus I3 into s plus 2 is equal to 0. Okay, so now this is equation 3. So therefore expressing equation 1, 2 and 3 in matrix form, and you will get the equation as s plus 1 s minus 1, s plus 1 s minus 1. Second is s 2s plus 1 1, and the other one is minus 1 1 s plus 2, I1 I2 I3 is equal to SV1 0 0. This is the equation you get. Okay, so finding the value of I1 first, and you have SV1 V1 into S. Alright, V1 into S. Okay, V1 into S 0 0 S 2S plus 1 1 minus 1 1 S plus 2 by, and over here you have S plus 1 S minus 1 S 2S plus 1 1 minus 1 1 S plus 2. Okay, so now let's write the answer. So here first I will multiply, so you will get V1 into S into, okay, and this will be when you cross multiply these two, you will get 2s square plus 2 2's are 4, so 4s plus s is 5s plus 5s plus 2 and that's these two minus 1 by, here also s plus 1, so s plus 1 into, and the same thing over here, right? Same thing over here, 2s plus 1 is nothing but 2s square plus 5s plus 2 minus 1. Okay, minus s into, let me see, you will get s square plus 2s, s square plus 2s, minus of minus becomes plus 1. Okay, and then you will have minus s, here you have s, and here you have s plus 2s plus 1, s plus 2s plus 1, that is 3s plus 1. There. See, I'm not going to spend too much of time writing all the steps, okay, but if you are not that much confident, it is always better that you write extra steps. See, here you can see some of them I did calculation, right? So I just did mentally the multiplication. Okay, the advantage of that is that the time consumed will be very less, but you might make mistakes if you don't be too careful. Okay, so you can do this mentally, but as long as just try to do it with full attention. Okay, don't create any mistakes. One small mistake is enough to change your entire answer. For example, instead of minus, if I put plus over here, or instead of plus over here, if I put minus, see, all the things will result in change in the entire answer. Okay, so both speed as well as concentration is important when you are doing these kinds of problems. So where am I? Yeah, okay, so here you get I1 is equal to V1 into S into, here you get 2s square plus 5s plus 1, 2s square plus 5s plus 1 by, here this is again also same thing, so it means this will be s plus 1 into 2s square plus 5s plus 1. Okay, and here you have minus s cube minus 2s square minus s, minus s cube minus 2s square minus s, and here you have minus 3s minus 1, minus 3s minus 1. Okay, so this is also equivalent to V1 into s into 2s square plus 5s plus 1 by, and here you have, I'm going to multiply these two now together, so you will get, it's going to be very long. Yeah, so you will get 2s cube plus 5s square plus s plus 2s square plus 5s plus 1 minus s cube minus 2s square minus s minus 3s minus 1. Now let me see if I'm very lucky that something will get cancelled. Yeah, this will get cancelled. That is, this plus 1 and this minus 1 will cancel each other. Oh, and this 2s square and this minus 2s square will cancel each other. Are there any other similar terms? What about this s? Here s plus 5s is 6s. 6s minus s is 5s. 5s minus 3s is 2s. So no, none of them is getting cancelled. That's it. So which means you will get, the answer is v1 into s into 2s square plus 5s plus 1 by, and here you will get 2s cube. No, 2s cube minus s cube is s cube. So it is s cube. Okay, and here it is s square, and there is no other s square over here, so it is plus 5s square. Here you have s, yeah, we already did that, right? It is s plus 5s is 6s. 6s minus 4s is 2s, so plus 2s. That's it. That's it. There's no other terms. That's it. So which means now here you can take s common, right? You can take s common out, and that s and this numerator s will cancel each other. So you will get v1 into 2s square plus 5s plus 1 by, here you have s square, s cube will become s square plus 5s plus 2. So therefore I found the first answer, that is I1 by v1 is equal to 2s square plus 5s plus 1 by s square plus 5s plus 2. Okay, now next I'm going to find the value of I2. So I2 is equal to I2 is equal to, again looking at the matrix, you have s plus 1 s minus 1, s plus 1 s minus 1. The second column will be this one, sv1 or v1 into s 0 0, and here you have minus 1 1 s plus 2 minus 1 1 s plus 2 by, and your denominator will be the same, s plus 1 s minus 1 s 2s plus 1 1 minus 1 1 s plus 2. Okay, and this will be equal to, here it will become minus v1 into s into, let me see, s square plus 2s, s square plus 2s, minus 1 minus becomes plus, so it becomes plus 1 by, now for the denominator you don't have to do this entire calculation at all. You can simply write the final denominator that you got over here. That's this one, right? That's s cube plus 5s square plus 2s. So you'll get s cube plus 5s square plus 2s. Okay, so like I said, the reason why is because so like this I have saved so many times, right? I have saved so many I have saved some time to finish the answer, because here you can see that I skipped some of the steps, right? And I am confident that what I have written over here is correct, because I already did this problem before actually doing this video. Before actually recording this video, I already did this problem, so I know that all these answers are correct. That is why I am, that is why I'm sure this answer is correct. Okay, and that is why I am writing this same answer over here. So that is what I'm saying. If you are very confident that what you have written so far is correct, then you can use the same denominator. You can substitute that value over here, so that will save a lot of time. You see, that is what is the an advantage of being fully attentive to your problem. Never get distracted when you are doing these kind of problems. You need to completely focus on nothing else but onto the paper. All right, focus nothing else onto the answer, and then keep writing. Practice is the best method. Okay. So here, like I said, I can cancel s over here, right? So therefore you will get minus v1 into s square plus 2s plus 1 by, and here this will become s square plus 5s plus 2. So therefore you will get I2 by v1, right? I2 by v1. So you got I2 by v1 is equal to minus s square plus 2s plus 1. S square plus 2s plus 1 is actually s plus 1 the whole square, but no use of writing like that. S square plus 5s plus 2. s square plus 5s plus 2. Actually, if you want to write like that, if you want to find the poles and zeros, that you're going to learn that in the next video. Okay, so this is I2 by V1, this is I1 by V1. Now what do they ask us to find? What do they ask us to find? They ask us to find I2 by I1 also, right? So I2 by I1, so which means I2 by I1 is equal to this answer. I2 by I1 is equal to how do you want to do this? I2 by V1 into V1 by I1. Okay, and what is I2 by V1? This answer over here, that is minus of s square plus 2s plus 1 by s square plus 5s plus 2. This is I2 by V1 into, and V1 by I1 is the reciprocal of this, so which means s square plus 5s plus 2, s square plus 5s plus 2 by, and here it is 2s square plus 5s plus 1, 2s square plus 5s plus 1, 2s square plus 5s plus 1, and yeah, these two will cancel each other, so your answer will be minus of s square plus 2s plus 1 by 2s square plus 5s plus 1. Okay, this is your answer. This is I2 by I1. So this is how we do the problem.